Okay, let's see how we can use completing the square in order to do integral problems. So I'm going to make this a little bit bigger here so we can see what's happening. So we have this thing on the bottom, x squared plus 6x plus 13. So normally what I would do first is I would try straight up u substitution. But if I let u equal all that stuff that's in the bottom, the derivative of that is 2x plus 6. And I don't have a 2x plus 6 hanging out anywhere else in the integral. So u substitution is not going to work on this problem in the traditional sense of u substitution. So what I'm going to do is I'm just going to focus on this x squared plus 6x plus 13. I'm going to do that over here. I'm just going to write that down. And I'm going to complete the square on this. Now, this is going to be a little bit different than the example video I did on completing the square because this is an expression. It's not an equation. So I'm going to have to figure out how I can keep this thing balanced even though it's not an equation. So what I'm going to do is I'm going to group the first two together, x squared plus 6x, and then I've got this plus 13 over here on the end. We'll worry about him later, okay? And I want to focus on that x squared plus 6x. Remember, I want to take half of my b term. So b in this case is positive 6. Half of that is 3. So I'm going to get x squared plus 6x plus 3 squared. Okay, now remember, we just added 9 to this problem. Normally, we would add 9 to the other side of the equal sign to keep everything balanced, but we don't have an equal sign here. So that's where this 13 is going to come into play. If I have 13, I don't want to add 9 to that. I want to subtract 9 from that. Because if I add 9 here, and then I subtract 9 here, I've essentially kept the whole thing balanced. This thing is still equal to the original x squared plus 6x plus 13. So what I want to do next is I want to factor this perfect square trinomial into this binomial squared. So remember, I told you the x comes from the x squared term, and the 3 comes from this 3 squared term. And then over here, I get 13 minus 9 is 4. So what I can do is I can rewrite this integral as 1 over x plus 3 squared plus 4 dx. And now I don't know if this looks familiar to you at all, but this can be written as u squared plus a squared. Remember when we were doing the integrals that result in inverse trig functions? This looks a lot like an inverse tangent problem. So what I'm going to do is I'm going to figure out what a and u are. So a is going to be the square root of 4, which is 2. And u is going to equal whatever I'm squaring here. So in this case, x plus 3. And as always, when we have a u, we need a du. So the derivative of x plus 3 is just 1 dx. And I am going to rewrite this integral as the integral of 1 over u squared plus a squared. And then the dx and the du are equivalent. So this is now a du. And I have just converted this ugly, ugly, almost nearly impossible integral into one that we did 2 videos ago. All right, I'll go purple here. This is now the inverse tangent. And if you remember, that formula is 1 over a times the inverse tangent of u over a plus c. So this becomes 1 over a, which is 2, times the inverse tangent of u over a, so that's x plus 3 over 2, plus c. And that is how you do integrals with completing the square. Let's take a look at the next problem. Maybe. Oh, there it is. Again, I'm going to pull out. I can't do a traditional u substitution here because it's x squared minus 10x plus 34. The derivative is 2x minus 10, and I don't have a 2x minus 10 hanging out. So I'm going to complete the square. I'm going to group the first 2 terms together, and I have that plus 34 on the end. Half of negative 10 is negative 5. So I'm going to add negative 5 squared, which is 25. But then I also have to subtract 25 to keep everything balanced. So this factors into x minus 5, the whole quantity squared, plus 34 minus 25 is 9. Look how it always ends up to be a nice perfect number. That's by design. So I can rewrite this integral as 1 over, and remember I told you about the dx. You can either have it on the top or on the side. Don't let that trip you up. So 1 over x minus 5 squared plus 9 dx. And I'm going to use my u substitution. My a is 3, my u is x minus 5, and my du is just dx. So this is the integral of 1 over u squared plus a squared, which again, conveniently, is my inverse tangent. So inverse tangent is of u, which is x minus 5, over a plus c. And that is how completing the square ends up as an inverse tangent problem. The more you do these, the easier they become and you start to notice some patterns. Okay, so let me see if I can get one of these problems in. I got about 7 minutes before the bell rings, and you guys, actually it's a 3-6 day, so 7 periods coming in. So see what I can get done here. Okay, so this one has a square root in the bottom. Now the last ones didn't have square roots and they ended up being inverse tangents. This one has a square root in the bottom, so I'm thinking it might be an inverse sine problem. And if you remember, we get the integral of 1 over the square root of u squared minus a squared du was what we were looking for. That was the template for the inverse sine formula. So I'm going to try and get this thing to look like that. All right, I need this space, so I'm going to erase this. So the first thing I'm going to do is I'm going to write it. This one has like an extra little trick in it that you have to be careful of. So I'll try and slow down when I get to that point. I am going to rewrite this so that it's in descending order. And one thing that we haven't encountered yet that is supremely important when you're doing completing the square is that the coefficient of x squared has to be positive 1. And that's not the case in this problem. The coefficient is negative 1. So what we have to do is we have to factor a negative 1 out of the first two terms, just the first two terms. Don't worry about that 3. We're going to leave him on the end there. So negative 1, if I factor that out, I'm going to get x squared plus 2x. I'm going to close my grouping symbol, and then I still have that plus 3 on the end. And now I just have that negative 1. I'm going to complete the square just like I normally do. But again, there is a little trick in there, and we'll talk about that as we get closer to it. But I have my negative 1. Let me complete the square in here. I have x squared plus 2x plus half of 2 is 1. So I'm going to add 1 squared. And then plus, and I have this 3 here. Now, normally you'd be going, hey, Miss Fulmer, you need to subtract 1 squared. You need to subtract because you just added 1 squared. So you have to do the opposite and subtract 1 squared to keep it balanced. But don't forget that we have this negative 1 out in here. If I distribute that negative 1, I actually am subtracting 1 in the first part of the problem. So to rectify that, I have to add 1 in the second part of the problem. And if you don't believe me, you can pause the video and you can multiply all of this out and you're going to see that it gets back to the original. All right, so that means that I can rewrite this as negative 1 times x plus 1 squared plus 4. I don't like that order. I'm going to flip it around. 4 minus x plus 1 squared. And I just realized my inverse sine formula, I did it wrong when I wrote it before. I had it u squared minus a squared, and it's really a squared minus u squared. I just realized that I said that wrong earlier. I apologize for that. But now this looks a lot like this. So this becomes the integral. I'm going to pull my 7 out. 1 over the square root. I never make this long enough. 4 minus x plus 1 squared dx. And then I can do what I did in the last problem. I can figure out my a, figure out my u. So my a is 2, my u is x plus 1, and my du is 1 dx. So I get 7 times the integral of 1 over the square roots of a squared minus u squared du. And that is, I don't have enough room over there. I'm going to come down and do it. That's inverse sine. Oh, I have a 7 out in front. I forgot. Inverse sine of u over a. So x plus 1 over 2 plus c. Now I'm running out of time. So here's what I'm going to do. I want you to pause the video. And I want you to try this problem. Again, you got negative x squared plus 10x plus 11. Factor that negative 1 out, just out of the first two terms. See if you can do that problem. I want you to pause the video. And while you're paused, I'm going to quickly write the answer to this problem. You should have gotten 7 times the inverse sine of x minus 5 over 6 plus c. And if for some reason you were not able to get that for this problem, let me know and I'll do that one in class on the board. Okay? All righty. I hope that wasn't too long of a video. Bye.